Hey guys, we're back. This is lesson 5.2, graphing polynomials and then identifying their features. And this is a very tech heavy lesson. So you want to have your TI-84 calculator or your emulator up during this lesson. And you're going to do a lot of pausing on the lesson because you need to be playing with your calculator the same time I am as well. So the first thing I think we need to do is just that. Let's type our function into y1 into our calculator. Now when I show you my emulator, you're going to notice that I have a whole bunch of functions typed in because I'm very slow typing on this, so I went ahead and typed every function we're going to need for the whole lesson. But you'll notice the only one that has an equal sign that is emphasized is the first one. So when I go to graph my function, the only one that will actually actively graph is that first y1. So in your y1, please pause the video and type in 3x squared minus 9x plus 1. And then we're going to look at this in the standard viewing window. So please have that typed in. And let's go to zoom 6. That's the standard viewing window. It's a quadratic. I think I should have been able to tell you that before I looked at the graph. So the degree being 2 means we're going to have a quadratic. I'm not surprised by its shape. And there we go. So here's some vocabulary for you. The first question that it asks you to identify are your x-intercepts. Oops, I want that smaller. So your x-intercepts, oh man, come on thing. Your x-intercepts are where they cross the x-axis. And I don't have that great of vision, guys, but I can kind of estimate where they cross the x-axis, but I can see from the picture it's not going to be at an integer. So we're going to have to use our technology to do this. So what we're going to do is we're going to use our calc menu. So you might want to write some notes to yourself kind of on the margin here. For your x-intercepts, you're going to go to your calc menu, and we're going to choose number 2, which is the zero finder. Where'd you go, calculator? Come back. All right. So I'm going to go to the calc menu, second, trace. And then number 2 is the zero finder. Now, what I'm going to do is I'm going to erase that ink. Because now that I've pulled up the prompt for zero finder, it's going to give me some instructions. And I have to find them separately, unfortunately. So I'm going to try to find this one first. And then the prompt at the bottom says left bound. You just have to make sure that your cursor is to the left or before it crosses the x-axis. So right now I already am to the left of it, but if you're not sure, you can just use your left arrow and kind of scooch a little bit. So get before the x-intercept, and once you're there, hit enter. And then right bound, you use your right arrow and scroll to the right of it. So that way you're going to be underground, if you want to think of it that way. All right, so now you're after the x-intercept. Enter. And then when it says guess, I just hit enter. And there we go. So I'm going to need to round to the, let's go 100th spot. So actually, does it say? No, it doesn't. All right. So I'm going to go to the 100th spot. So 0.12 that would round up to. And notice the y value of that ordered pair is 0, which makes sense because it's a 0. Now I am actually going to write down the whole ordered pair. I'm going to say 0.12, comma 0. If you just wrote x equals 0.12, that does make sense for the problem because it's an x-intercept, so we know the y is 0, but I like the whole ordered pair. Now remember, on our calculator, instead of scooching left and right with my arrows, I could just make some estimations and then some guesses. So like for instance, this x-intercept, let's see, that's 1, 2, it's about at x equals 3. It looks like it's a little before x equals 3. But when it asked me for those same prompts again this time, so second, trace, go to the zero finder, number 2. When it says left bound, I just have to type in an x that I know is before the x-intercept that I'm looking for. So I'm just going to type a 2. Rather than using my right arrow to scooch over there, I'm just going to type a 2. And then when I hit enter, it moves itself, which is really nice. All right, so there's a left bound, excuse me. Now it says right bound. Right bound. So it needs a number after the x-intercept. So if I think it's about at 3, I'm pretty sure 4 is after it, so I'm just going to type a 4. And then I can type in my guess of 3 if I want, or I can just hit enter when it says guess. Kablamo! Alright, 2 things happen here. First of all, we have this icky 0, which I anticipated, so just before 3, we were right, 2.88. And then this happens. This happens sometimes. It's a pixelation issue on your calculator. and it's doing calculus on what really is kind of a jagged pixelated picture. -1e -10 means -1 times 10 to the -12, excuse me, power, which is a teeny tiny negative number. It's like negative point and then a whole bunch of zeros, like 11 zeros, and then a 1. Well, I think we can all agree that that number, with it being so tiny, is really stinking close to 0. So anytime this e shows up in your calculations, just know that it's a pixel issue on your calculator, and it really means 0. So finally, we have the other x-intercept, which was at 2.88, comma 0. All right, and that was it. So now when I look, I need to get rid of some of my ink here. Now when I look at my curve, my polynomial, it asked me for a maximum. Remember, a maximum would be like a dip on the roller coaster, you know, like going up and then down. We don't have a maximum on this parabola. Parabolas only have one absolute max or min, and this one happens to have a minimum. So on my paper, I'm going to say none for maximum. There is a minimum though. All right, so we're going to use our calculator. And our minimum is this guy right here, right? That's our minimum. Well, we've done this before in the quadratics lesson. We found minimums using the calc menu. If you remember, we went to second trace, and then we chose the appropriate prompt. So in this case, it would be minimum, number 3. All right. Now, sometimes minimums are just easier to scroll, right? So I'm going to use my left arrow, and I'm going to scooch my cursor so that it's before the minimum occurs. So before it over here. So once I'm over there, hit enter. And now it says right bound. So I'm going to use my right arrow and I'm going to scooch so that I'm a little after the minimum occurred. Hit enter. And then when it says guess, just be done, guys. Enter. All right. So now I need to write down the whole ordered pair. The whole ordered pair. And this is another pixelation issue, guys. I think by 1.4999999, they're referring to that as being 1.5. So I'm just going to write down 1.5 negative 5.75. The other thing I need to write down on my notes would be my calculator prompts. So we went to calc again, and then we chose number 3, the minimum. Wow. Maybe if I write over everything, it'll be easy to read. Not. Okay, so at this point, what I need to do is I need to get myself a pretty decent picture. That's going to be pretty challenging for me because I'm not capable of drawing a pretty decent picture, but that's okay. All right, so one of the things I know I can graph would be the 2 x-intercepts. So 0.12 is like right after the origin, and then 2.88 was right before a 3, and then that minimum we found was at 1.5 negative 5.75, so about right here. And then everyone's in for a treat as I try to graph this. All right, Abruzzo, square your shoulders, girl. Here we go. I'm going to use blue ink so it actually shows up on my paper here. I held my breath that entire time. I was so nervous. Okay. That actually wasn't too bad, okay? So that's a kind of parabola. It kind of looks like what's on my graph there. If you wanted to be more accurate, you could plot some more points. But guys, I'm telling you, it doesn't matter if I plot 3, 5, 11 points. I can't graph. All right, so this next part is where it gets a little tricky, okay? My curve, it looks something like this. So the first thing I'm going to do is kind of, I'm going to draw the curve with no arrows on it, okay? None. Think of this like a roller coaster, all right? On this piece of the roller coaster, it's moving down, right? Negative, decreasing. And then it hits the bottom, and then it turns around and it starts moving up. And that's what my roller coaster is doing as far as what we call increasing and decreasing behavior. So what I would like you to do is underneath this weird little sketch, draw yourself a little number line, and the only number that goes on the number line would be the x value of what we call a turning point. So bust out some highlighters. A turning point would be a maximum or a minimum. So this guy right here, the x value of the turning point, is what goes on my little line here, because that is the time that my roller coaster switched from increasing to decreasing. So 1.5 right there. Now, we're in for a treat. I love talking about roller coasters, right? before we hit 1.5, my roller coaster was decreasing. So you can either put like a negative symbol like this, or you could literally write DEC, or you could write the whole word, decreasing. But then after 1.5, my roller coaster was increasing. You can write INC, you can put a green plus sign like I did, but that's the domain interval for which we have increasing and decreasing. All right, sorry, I was just interrupted a little. Now I can't remember where I was. Okay, so we're coming up with an interval for where the function is increasing and where the function is decreasing. So I think that number line look is a little easier for us to look at. So it's increasing on this domain. That's how we want to read it, right? So it's increasing from 1.5 and then to forever, right? And doesn't infinity live over here? So always use a parenthesis on increasing and decreasing roller coaster questions, because at the point at the bottom, it's not really increasing, nor is it decreasing. It's kind of flat. So it's increasing from 1.5 to forever. But it's decreasing in this section, right? So you got to read it left to right. So it's decreasing from, think about who lives here, negative infinity to 1.5. And again with a parenthesis. Yikes. All right, so these questions can be really, really tough. I think the increasing and decreasing roller coaster questions are the worst part of this whole problem. So we have to just really stop and think about, okay, how do I read this, what is essentially a domain interval? And then we're definitely going to be doing a lot of examples of this during our Google Meets, because that's probably the hardest part of this question for sure. All right, let's take a look at this next question. We have a cubic this time, and you need to, well, Bruzo, you need to get rid of your ink, but y'all need to type that function into y1. What I'm going to do is I'm just going to delete y1, oops, clear it, and I already have it typed into y2. It doesn't matter where you have it typed in, but I need to turn mine on. And then again, notice I have other functions, but you aren't typing those yet, okay? You're just going to type the 5x to the third plus 4x. So please pause the video and get that new function typed into y1 or y2 or y3. All right, so we're going to again look in the standard viewing window, and remember a cubic is a weird little squiggly thing. Yep, that's what a cubic looks like, all right. So we're going to go and find everything on our calculator like we did in the previous question, starting with the 0. So I can kind of tell, I'm pretty sure the 0 is actually at 0. But in order to find my 0, and I don't want to be tricked, I'm going to use my calculator, and I'm going to go to the calc menu. And again, zeros are found by choosing number 2, the 0 finder. So I'm pretty sure the 0 is at x equals 0. So when it says left bound, you can either use your arrow and scooch to the left, or I could have typed a number like -1. And then for right bound, I'm going to scooch to the right, or you could have typed a number that's to the right of 0. I could have typed like a 1. That would have worked great. And then when it says guess, I just hit enter. And what do you know? There is totally a 0 at 0. So our x-intercept is at 0, 0. So again, writing a little note to self, we chose, everything's in the calc menu, so I'm just going to say number 2, the 0 finder. All right, this one's a little confusing to look at because it's asking for a max and a min, and people try to argue like, oh, there might be like a tiny bump right there. There's actually no maximum and no minimum here, so that's great news for us, guys. There's none. That's also great news for us because, and I could use my table to come up with some better points, but I'm too lazy and I can't graph well enough. Oh, gosh. Bruzo, that might be the ugliest thing you've ever graphed. One thing that I want to think about here, my shape that kind of looks like this. If this was a roller coaster and I'd be reading it left to right, that roller coaster looks awful. It would be increasing the entire time on its domain. So it is increasing from negative infinity to infinity. It always increases. And it's never decreasing. Weird. All right, what happened here? It's like a random weird title. I don't think that's supposed to be there. Ignore. All right, flip on the back of your notes here. We have a new function. we have 1/5, and then x minus 2, x plus 1, x plus 3. I'm going to type that into y1, or for me it's in y3. I need y'all to pause the video and get that function typed in. For me, I'm going to clear out the one we're done with, and I'm going to turn on that particular function by emphasizing or hitting enter to darken the equal sign. Alright, so pause the video and get that typed in. 1/5 x minus 2 times x plus 1 times x plus 3. And then we graph. Ooh, that's pretty. Now, interesting. My intercepts, my zeros, I'm kind of suspicious that they're actually nice numbers, because they're kind of looking like this one might be at -1, and this one kind of looks like it's at 2, and this one looks like it's at -3. And one way that I could check to see if that's correct, I could go to my table, and I could look at what happens at -3, -1, and 2, and then look at that, guys. We totally have zeros. So I actually didn't have to use my trace menu, my calc menu that time. I could have just looked at this, and then now there's a little note. It says this is factored. So we could have just found the zeros really easy by setting each one of these equal to 0. And by it, I mean the factors, right? So if I said x minus 2 equals 0, that means you're going to get a 0 at 2, right? 2, 0. And then same thing here, x plus 1 equals 0, you're going to get a 0 at -1. And then x plus 3 equals 0, you're going to get a 0 at -3. Okie dokie. Well, I can graph that, maybe. -3, -1, and 2. Alright. So on my calculator, they want me to find, ooh, it's not an eraser. There we go. What do they want? Oh, nothing. Well, never mind. Hey, you know what? Just for funsies, let's go find the max and the min so I can plot them properly. So, I will recognize that when I graph this, there's a little maximum bump right here. And then there's a little minimum bump right here. So, I already forgot. Oh my gosh, I have a goldfish memory. It didn't ask me for anything, that's why. I'm just going to go find the maximum first. So I'm going to use my calculator, and I am going to use my maximum finder. So second trace, choose number 4, the maximum finder. So when it says left bound, you need to scooch so that you're to the left of that bump. Scooch, scooch, keep scooching. That's good enough. All right, enter. Now I need to scooch so I'm to the right of the bump. Scooch, scooch, good enough. All right, enter. And then you can see those lines. That bump is definitely in the middle, so hit enter for the guess. Boom, we need to write that down. There's no way I'm going to remember that. Oh my goodness. I need a pen. All right, I don't have a pen. All right, negative 2.12. Meh. I already forgot. All right, max at negative 2.12, comma, what? 0.81. Yes, totally what I thought. All right, we're going to do something similar, and we're going to find our minimum using a similar command, but this time, remember, we need to pull up the minimum finder. So I'm going to choose the minimum finder to find that minimum there. So second trace, number 3 is the minimum finder. Okay, so technically right now you are to the left of the minimum bump, but I'm kind of far away and that makes me nervous, so I'm actually going to scooch. This sounds weird, but I'm going to scooch to the right a little bit so that way I'm close. All right, so I'm just to the left kind of the minimum. Enter. Now scooch so you're just to the right of the minimum. Good enough. Enter. Ooh, I went a little further than I wanted. That's okay. Enter. As long as your minimum is in between those two lines and there's no other minimums in the middle there, you're good. I can't remember that. 0.79, negative 1.64. 0.79. I already forgot. Negative 1.64. Oh, it stinks getting old. All right, so I'm going to go and try to graph these. And we all know this is a big joke because I'm not going to be able to graph nicely. That's okay, though. That's kind of where the minimum was. All right, the maximum is at -2, 1-ish. Close enough, Abruzzo. All right, and then make it all terrible by graphing. That was almost amazing. It got a little weird at the end where it went a little spiky, but, you know, that's okay. It's pretty good. All right, we got one more. Now, I think we can all agree that the less you have to use the calculator, the better. So I learned from the last question that if it's in factored form, we are going to see that the solutions are just, the zeros are the solutions to the factors. So I'm going to kind of use that trick again, where if I took this factor and I set them equal to 0, I know that this one here, I don't want to write x. What do I want to write? You know what? This is just a testament to how my day has gone, guys. Okay. This would be a 0 at 3, 0, and this one would be a 0 at -1, 0. Now, I actually want to graph this one with you before we talk about the next vocab word, because it's a weird one. All right, so go to y equals, Abruzzo, erase all your ink, and then pause the video and get that function typed in. I'm going to clear out that extra function. It could be typed anywhere. Just make sure you have 1/2 x minus 3 squared times x plus 1 squared. Quantities on both of those. Okay, once you look at the graph, and remember, we already interpreted there to be a 0 at 3 and a 0 at -1. I didn't turn it on. This is real life, guys, okay? All right, I'm going to turn it on. And now I'm going to look at the graph. Oh, interesting. All right, take a look at this. This is -1, right? And this is 3. Something weird happens there, guys. First of all, the shape is amazing. It looks like a W. That's cool. And it bounces. It, like, doesn't even come through the axes. So let me explain to you what's going on here. Because we had exponents on the factors, we had an exponent of 2 and an exponent of 2. This polynomial has what we call double roots. This is known as multiplicity. So when one of your factors shows up more than once, and they're going to indicate it typically with exponents. So this means x minus 3 and x minus 3 would be twice, right? And this means x plus 1, it would be twice. So if it shows up with multiplicity, something strange happens to your graph. If it shows up an even number of times, so to the 2nd power, to the 4th power, to the 6th power, it's going to bounce off the x-axis and not actually come through and cross. So it never actually goes negative in this case. So in this problem, the graph bounces off at the points, like we just said, 3, 0, and -1, 0. So that was exciting. All right, so -1, 0, and 3, 0. And I might want to find some other things on my calculator, if not for anything else other than to practice. Well, I already know where those two minimums were. These minimums are also our x-intercepts, or our zeros, I should say. So these were minimums. That was cool. So if they asked me for minimums, I wouldn't have to find them again. But there is another what we call relative max. So let's go find that relative max using our calculator. I'm going to go to the calc menu. And again, I'm choosing the right command. It's a maximum, so number 4. Okay, so now what they want from you is they want your little cursor dude to be a little bit to the left of the maximum. And actually, I'm already there, so I'm going to hit enter. Now it says right bound, so use your right arrow and scooch, scooch, scooch until you're after the maximum, to the right of it. Hit enter. And you can't see it, but there is like a weird magenta line right here. So hit enter one more time. And I'm pretty sure they're trying to say the number 1 right here, right? 0.99999, let's call it a 1. So there's a maximum at 1.8. Yeah. So since I can graph so great, let's see what happens, man. W's are not my thing, man. There's no winning with this girl. She cannot graph. All right. So that's kind of it. I know that lesson seemed like there's a whole blob of information. All right. Here's what I'm going to tell you. This stuff on identifying x-intercepts and turning points and increasing and decreasing intervals. The finding x-intercepts and finding the maximum and the minimum, super important for Algebra 2. We're going to do that a lot. The domain interval for increasing and decreasing, that's really just funsies for me as your possible pre-calc teacher next year, okay? My friends who are moving on to college algebra, advanced algebra, pre-calc, calculus, they do graph investigation a ton, and that's a huge concept. For those of us who are like, this is my last train stop of algebra, I am done after algebra 2. Don't get hung up on the increasing, decreasing thing, okay? It's a big concept for future math classes. It's not a big concept to like function as a human. All right. So using our technology to find all of this is what's really cool today. All right. Make sure that your notes are filled out in a way where you can kind of go back to your graphing calculator and follow along. I'm sure we're going to ask you to do some Flipgrid or something where you show us using the calculator and using it effectively. So make sure that you've practiced using the calculator. All right. That's about it. Good luck, everybody.